Welcome to this section on scrolling lists in Xamarin.iOS. In iOS, scrolling lists are called table views. In Android, they're called list views, just for reference. We're going to discuss exactly what a table view is, what all the parts are, what they do, and how they affect each other. Then we're going to create a basic table view with a standard cell. Now, most tutorials out there, I know because I've looked at most of them, only tell you how to do this with a table view controller. I'm going to take you from the ground up to give you a good understanding in how a table view works. Then we're going to create the number one feature that most apps need, and that is a custom cell. You would hardly ever have a basic table view with just one label on it because it looks boring and you can't change the font or anything like that. Then we're going to create sections with headers and footers that allow our user to see where they are in the app or in the scrolling list. We're also going to create a little index on the right-hand side, and when the user touches that index, they can navigate to certain parts of your list view according to how you've set up your sections. Finally, we're going to look at how to customize the look of those headers and footers. So let's get started. So what is a table view and what is a table view source? Well, I've explained them really simply here using Lego. And over on the left-hand side, we have our table view sitting on a screen of our app inside our phone. Now, the table view contains a bunch of cells, which are these blue blocks going across here. A table view source is simply a class that hands these cells into the table view. The table view source also keeps count of all of the cells that are there and keeps track of each one. Now, where does the table view source get its cells? Well, it can either create a brand new cell, pop some data in it, and then send it to the table view. But creating a new cell is programmatically expensive, so we want to try and avoid that if we can. When we first start up our table view, we have to create new cells. But as we use our table view and we scroll it, these cells, let me just move this, start scrolling off of the screen. And then what the table view source does is identify those cells, grab them, and bring them back to be recycled. So a table view source will create a new cell unless it can provide a recycled cell. The final piece of the puzzle is the list of data, and the table view source grabs the list of data and plants it onto each new cell, and it's then shown to you in the table view. That pretty much sums up table view and the table view source. Let's create our list app in Xamarin. Go ahead, click New Solution. We want an iOS app, and this will be a single view app. Hit Next, give it a name. I will call this List View App, and let's accept the defaults, project name, etc. I'm going to turn off, well, I'll leave Git on actually, so I can upload this for you later, and hit Create. Now, there are two ways of integrating lists into your apps. And typically what you'll see out on the internet is the first way I'm about to describe, which is a table view controller. Now, a table view controller is a view controller that happens to have a table inside it. Because it's a special type of view controller, we can't actually add any other elements apart from the table view into it. And most tutorials you see out there actually only go over a table view controller. We want to get the table view from scratch, which allows us to understand exactly what is going on with our app. So in this tutorial, we are going to do it completely from scratch, and then in the future, if you want to use a table view controller, you can do so and also know exactly what's going on. Let's open up our main storyboard. And we have our main scene as usual. Over in our toolbox, let's scroll down and see what we have. So first we have this table view controller that I referenced before. And if I drag one in, it creates a whole new view controller with a table view embedded. And you'll notice that I then cannot go and embed other things like a label. It kind of gets shoved up towards the top. So I'm going to undo that. And what we're going to do is put our view controller into this main one that we already have here. So in our toolbox, let's search for table. We want the table view. Let's drag it in. And I'm not sure that's actually done it. Let's try that one again, shall we? I'm just going to try and zoom in because sometimes Xamarin is a bit funny about actually dragging things into this view. So let's try that one once again, shall we? Table view. Right, there we have it. Now that it's in, let's select it, and over in the name, there we go, over in the name, just make sure below there the class says UITableView to make sure we have the table view selected. So the name, let's just call it table view. That's with a lowercase t. Then let's put some constraints on it. So if you click it twice, we can drag these constraints over to the sides and we can make them 0 if we wish. And the same on the other side. And of course, let's do the bottom and the top. So I'll start with the top and go to the top layout guide. Now you'll notice, this is just another constraints tip for you, that top item there doesn't go all the way to the top of the screen. It actually only goes part of the way. And that's to allow room for the status bar on the iOS device. So let me just click that, set it to 10, and then finally let's give this table view, actually let's pin it to the bottom because we don't need to do much else inside of this scene. But if you wanted to, you could have something like a switch at the top that would allow you to change whatever was in your table view. So I'll have that set as 0. And then we can update the scene. And our table view has now expanded. Now we have these items at the top that we can click. And these are the UITableView cells. And cells are the items that scroll up and down in your table view. Let's click our table view, and over in the properties panel, we want to change the number of prototype cells to just 1, because we're only going to use one kind of cell. So now there's only one cell to click, and when you do click it, have a look in the properties panel at the bottom right. You'll notice we can't set a name, and there are good reasons for that I'll go into later. We have a style for our cell. We have custom set to default. We can have basic, right detail, left, and subtitle. If I hit basic, this is just a cell with a single label inside it. I can hit right detail, and this is a cell with a detail button. The same with left detail. And subtitle has 2 labels, and one of them is smaller to represent a subtitle. So what we will do is select a basic cell for now. Later on, I'm going to cover creating your own custom cells. But to get the concept across of how a table view works, it's best to work with basic ones at first. The cell needs a reuse identifier. A reuse identifier is a unique string that allows the iOS operating system to grab your recycled cells that have come off of the screen when you're scrolling and then reuse them at the top as you're scrolling down. Why does it do this? Well, it's much more efficient to reuse a cell that's already been generated rather than going through all of the processing power to create a new one. So reuse identifiers are used for that. You must have an identifier. Let's call this table view cell. That's with a lowercase t. Now that we have our table view and our cell, it's time to go and create a little bit of data. Let's open up our view controller and we're going to create a basic list of strings to hold some dummy data that allows us to populate that list. So inside of our view controller class, let's have list, open brackets of strings. Right-click list and allow it to resolve using the system's collections generic. Let's call this list of strings table, or just item, let's call it table items. Then inside of our view controller, let's populate that list with some dummy data. Let's say table items is equal to a new list of strings. Then we need a loop to shove some strings into that list. Let's use a for variable I equals 0. And we want to run this loop until I is less than 40. And each time we run round, we'll add 1 to I, so I++. And then inside of here, we will have table items dot add, and we will say item number, and then we will add on the I value dot to string. So this will just go round and round and add 1 to each item number into our array. Okay, so we have our data. How do we transport that data to our list? We have to use something called a TableView source. And this, if you recall from the earlier video, is kind of the handler. It grabs the cells, it grabs the data, it matches them up, it allows you to do things when you click cells. So let's right-click our project, go to Add New File. Now, if you click iOS and you scroll down, we don't actually have a TableView source in here, which is a pity. It would be nice just to have it automatically set up for us. I know you can do it on Xcode. So we have to go General, Empty Class, and let's call this my TableView source. And it's created. Now my TableView source needs to inherit from the UI TableView source. And this is stored under UI kit. So let's click using UI kit. Now inside here we're going to store a copy of our list of items. So let's again create a list of strings. And let's call it table items. Then inside of our constructor, when we fire up this source, we want to pass over our list of strings. And I will call this underscore table items. And then we're going to make our table items equal to underscore table items. So we have our data passed over. Now begins the magic for the table view. We only need two methods inside of this as an absolute minimum, but they are required. The first one is an override rows in section. And Xamarin's doing its usual thing of slowing down yet again and giving me the beach ball. This is great. Xcode doesn't do this nearly as much. And it's back now, rows in section. And it will auto-complete it for you. What this method does is tell your table source how many rows it's going to need in the future and now. All it wants is for us to return the table items dot count. So we only need as many rows as we have items. Then the second method we need is again an override, and this is the get cell method. What this does is grab a cell to plant our data into and then show to the user. So var cell is equal to the table view, which is passed in here, dot dequeue reusable cell. And this asks us for an identifier. And if you recall, we set this as table view cell inside of our storyboard. And there's quite a bit happening in this line. It's not just dequeuing, it's also saying if one doesn't exist, then we'll go ahead and create one. If one is available for recycling, we'll use that. In previous versions of Xamarin, you might have to explicitly say, make a new cell. And as we go through this course, we'll get into that a bit more. But for now, it's grabbing the correct kind of cell to give back to our table view source. Then we want to set some properties on the cell, cell.text label, and this is the default text label that comes with those default cell types. .text is equal to our table items, and then we have to give it an index. So this is the index path dot row, and that is simply the currently selected row that's passed in here through index path. Finally, we have to return the cell, so it's ready for use. That completes the table view source, so we can switch over to our view controller. Now, in here, we're going to set the source of our table view equal to the table view source. There's an error that a lot of people make, and even I've made this, and no matter how advanced you get, you'll still make it, and you'll tear your hair out until you realize it's such a stupid error. A lot of people set the data source initially inside of the constructor. Now, if you're coming from a C#.NET sort of background, that might make sense, but in this case, when the constructor fires, the view hasn't yet been created. So if I try to access my table view inside of here, I'm going to get a null reference exception because it doesn't exist yet. Where you have to access it is in one of these view did load or view will appear methods. So inside of here we need our table view dot source is equal to new my table view source. It asks us for our list of items, table items, and we are good to go. Now if we run that, hopefully it will compile. It will auto-generate that list of 40 items. It will then grab a table view source and populate the list with all of those items. There we have it. And of course we can scroll down in the way that we expect from iDevices. So I'll just summarize what you've learned in this lesson. You've learnt how to drag a table view onto a storyboard, create a basic prototype cell. You've given that cell a special reuse identifier, which is the most important point you can pick up from this lecture. Then you created a list of objects that you were actually going to show inside of your table. You created the table view source that orchestrates the whole show, getting cells and putting data in them. And finally, you instantiated your table view inside of view.did.load. Currently in our app, we have a simple list view that uses the basic cell type. If you recall, a cell was this item here. Now, in reality, when you make your apps, you're going to want to customize this cell. You're not just going to display some text. You might want to show an image or more text in different locations with different fonts. So let's learn how to create that custom cell. Head on over to Xamarin. The first place we need to go is the main.storyboard. We need to select our cell. Make sure it's not just the label you've selected, but the actual cell. And then scroll down on the properties, and when it comes to style, hit custom. Now we have a custom cell ready to go out of the box. But as of yet, this cell doesn't know how to conduct itself as a cell. So let's create a class to fix that. Right-click our project, hit Add New File. Let's have an empty class, or we can click iOS and click Table View Cell. What I'm going to do is go the general empty class way, because I'm going to explain as I do things, so you have a better understanding of what everything is doing. Let's call this my custom cell. And it is created. First, we need to import some classes. We'll need the UI kit. We'll have to going back to my Swift there, we have to have a using foundation. And finally, we need core graphics, because we're going to be drawing things inside of our cell, and core graphics is the class that takes care of that. Come down to your class section, and let's make this inherit from a UITableView cell. Okay, so now we have a basic class for our cell. We need some elements into which we're going to put our data, so things like labels and switches. And we're going to create them here programmatically, so you can understand it from that point of view, as all we've used so far is the designer, and it's always good to have an understanding of the code behind. Let's define two UI labels. So UI label, heading label, and a sub-heading label. Right, inside of the constructor, my custom cell, we're going to pass over an NS string. This is just Apple's way of defining a string. And we're going to call this cell ID. And this is going to be equivalent to the reuse identifier that we played with in the last lecture. Then this is going to have a base class of UITableView cell style dot default. So this grabs the generic table view style and says, hey, I'd like to create a custom cell based on that. And this requires a reuse identifier, so that's just our cell ID. Then let's put some code in here to initialize everything. I'll show you first of all the selection style. Now this is just the color that the cell flashes up with whenever you select it. So we want a UITableView cell selection style dot, and we have blue, default, gray, or none. So none would give you no feedback that you've clicked it. I believe it's currently set to blue in the storyboard, so we'll leave it as blue. Then let's have a background color, and inside of a cell, the view that contains that cell is called the content view. Let's set the background color equal to UI color dot, and let's scroll down, and I'll choose cyan. Now it's time to create and place our labels. Let's have our heading label first, equal to a new UI label, and let's give it some properties. Let's give it a font, and let's make this equal to UI font dot from name. And if you jump onto Google and search for default Apple fonts, you can find a list of all of the fonts that it supports. So we're going to have Helvetica, and then it asks for a size of the font. Let's make it 17 float. Then put a comma because this is a list of properties. We can set a text color if we wish, equal to a UI color dot, and let's make this something really interesting like red. And then finally, let's set a background color, and let's make this UI color dot clear. And the reason is we don't want the background color of the cell to block the color of the table. Then let's finish that off and put our semicolon in. Now we need to do the same for our subheading label. That's equal to a new UI label. Let's give this one a font. UI font dot from name. And let's make this interesting. Let's give this American type writer. And then a font size of 12. We can also set things on here like text alignment. And this takes a UI text alignment dot. Let's make this centered. Let's also give this a text color of UI color dot blue. Of course, you can set any colors you like. And finally, we want to set the background of this equal to clear. And finish off that cell. Go ahead and save that file. Now we have our labels, but they haven't actually been added to the cell yet. And we have to explicitly do that. So content view dot add, and you'll see we have a lot of things. We can have constraints, layout guides, subview, and subviews. We're going to add multiple things, so it's add subviews. And we're going to create a new UI view because you'll notice it asks us for an array of UI views. So let's create that array, new UI view array, and then pass it over the heading label and the subheading label. And close off your brackets, and now they've been added to the cell. So we have the cell, we have the elements. How do we get our data into those elements? Well, with a custom cell, we need to create a helper method that allows us to transport that data across. So let's go public void update cell, and we're going to pass over a string underscore heading and a string underscore subheading. And then it's in here that we're going to set the text of our heading and subheading labels. So heading label dot text is equal to underscore heading, and subheading label dot text is equal to underscore subheading. Right, we have our data put in, but there's one thing missing. It's not obvious at first glance, and that is we haven't given our labels a position. So to do that, we first need to override one of the default methods, which is called layout subviews. And this takes all of the elements we've declared and lays them out for us according to where we want them. So previously, you worked in Storyboard and you used the constraints to decide where things should go, and kind of this part of the code was abstracted away from you. But this is really what's happening in the background when that goes on. So we have a heading label dot frame, and frame is the square or rectangular area where we're going to put the heading label. And a frame requires what's called a CG rect. So type new CG rect, and then CG rect requires an X and a Y position, and then a width and a height. So the X and Y, I want it somewhere near the top left corner. So let's have 5, 4. Then it requires a width. Well, I want this label to go the full width of my cell. So we can get that by saying content view dot bounds dot width. So this looks at the whole cell once it's been rendered and then grabs the width from that. And then it needs a height. Let's give this 25. So now it's got a frame. Let's do the same with the subheading label dot frame is equal to new CG rect. And let's place this somewhere like 100 points in, 22 down. Let's have it 100 wide and 20 deep. Okay, that concludes making our custom cell. So we have layout subviews, we have an update cell, and we have an initializer that passes over the cell ID that we use to reuse the cell. We have one further action to do. That is in our TableView source. Inside of getCell, we need to modify what this cell is exactly. So the first thing we have to do is remove this cell.text label, because that doesn't exist anymore. Or it does exist, but we don't actually want to apply it. And we say our cell is equal to DQ, a reusable cell. And then we have to cast this. So we're going to say as my custom cell. So we're saying when you get the cell, it's going to be a my custom cell. Then we have to check something. We have to say if the cell is equal to null, so the cell doesn't exist, then we have to create it. So cell is equal to a new my custom cell, and this requires an NS string for the cell ID. So this is new NS string, which is in the foundation class, and you pass it over a string, which is our table view cell. Close off all of our brackets. Now that we have our cell, we can update it. Cell.update cell, and that's the method that we created earlier. Pass it over our data. At the moment, we only have a single array of strings, so I'm going to pass it the same string for each heading and subheading. So let's have items index path dot row and pass it the same thing again. Index path dot row. Close off our brackets, and then there are no errors, so we should be good to go. Let's run this in the simulator. So at the moment we have our old app there, which is this single item, and now we have our new one where we've set a different background to our thing, and we've put in our new labels. One little thing that's annoying me is this grey thing won't go away. So let's discover how to do that. Let's stop it running. Inside of my TableView source, let's override, and we want row selected. So this is the method that gets called whenever a cell is selected, and it sits inside of your TableView source. Now, by default, iOS likes to highlight when you've selected, but iOS doesn't automatically unhighlight it. We have to do that. Let's have TableView dot deselect row, and this requires some arguments. It wants the index path, which of course is already passed in, and it wants animation. We'll set that as true. Now let's run it, and when we click it, it should highlight and unhighlight for us, which is a behavior that we expect from iOS apps. So there it goes. Okay, so that's how you deselect it. There's one final thing I want to show you, and that is to change the height of your custom row. So this is again an override inside your TableView source. And let's type height, and we have get height for footer, for header, or for row. Let's select row. Let's return 75F. I believe rows are normally 45 or 55, somewhere around that value. So 75 should be a little bit larger. And there we have it. We have a much larger row. Actually, from memory, the row height is 44 by default. Okay, that concludes how to create a custom cell. I'll just run through the steps. Main storyboard, change your cell to custom. Create a custom cell class that implements a constructor with a cell ID, has a method called updateCell, and has layout subviews to lay out your various elements. Update your TableView source, where you dequeue your cell, and if it's null, create a new one. Update your cell below that. Change your row selected to deselect the row after it's finished selecting. And optionally, to change the height, hit Get Height for Row. Let's look at sections inside of our app. So this scrolling list of stuff isn't too long. We could scroll through it. But if we had a list of, say, vegetables, animals, fruit, whatever it was, it would be nice if there was some way of grouping them together into sections and then providing an index on the right-hand side of our screen that allowed us to jump to those sections. If you open up your iPhone and have a look at your Contacts app, you'll notice something like this in action. All your contacts are arranged alphabetically, and you can shortcut to the appropriate letter that starts the name off. So over in Xamarin, let's go over to our view controller, and what we're going to do is remove this table initialization. We're going to have table items dot add, and we're going to add a couple of strings like an apple, and then I'm going to copy that, and then I'm going to have an aardvark, Let's have a bee and a butterfly. Finally, let's have a zebra. Okay, so I have those items. Now, over in my table view source, let's change this height for row to something really ridiculously large, like 250. Right, I'm just going to hit play to see what that looks like. And I know it's going to look ridiculous, but it will all become clear why I'm doing this in a minute. So now I can scroll down between my cells and select them. Great. Okay, inside of our table view source, the first thing we have to do to create an index is to index our items that we've transported over. Because at the moment there's no way that our source knows how we should arrange them or how we should group each item. So it doesn't know that things that begin with the letter A, like apple and aardvark, should be grouped by A. We have to explicitly create that grouping. To do that, we're going to use something called a dictionary. So right at the top, inside of our class level variables, let's go ahead and create a dictionary. Dictionary, string, list, string, close off our triangular brackets, and let's call this indexed table items, not tabvel, table items. Now, what is a dictionary? A dictionary is exactly like a real-life dictionary. We have an index, which is a string, and that can be anything we like. But if you looked at a dictionary, you would have 26 indexes starting from A, going through B, C, D, and ending in Z. Then inside of each item, each key, if you will, we have all of the words in the dictionary. And this is exactly the same. So we need a little function that allows us to pull out all of these strings that we've transferred across and arrange them into sections just like a dictionary. The best place to do that is inside my table view source constructor. Let's have indexed table items is equal to a new dictionary string list of strings. So we've initialized it now. Then we're going to have what's called a for each loop. And a for each loop goes through a list or an array of variables and increments them one by one, goes through them one by one until there are no variables left, and then the loop ends. And what are we going to loop through? Well, we're going to grab variable t in items, in our table items rather. So this loop is going to go through, grab a variable called t, which represents an element from table items. Now we have to check if our dictionary contains the key of the current item we're looking at. So if indexed table items dot contains key, and what is the key? Well, the key is going to be the first letter of our string. So T naught, that is the first letter, and we have to convert it to a string and close off all of our brackets. Open our brace, and it's saying if our index table item dictionary contains this key, then what we're going to do is index table items of key T naught dot to string. This is a bit convoluted, I admit, but it's one way of doing it. Then I would like you to add the current item, which is T, to that section in the dictionary. So it's grabbing this section and then adding our word to it. Of course, we could have a case which is else, and else is if we don't already contain the key. So of course we need to add the key. Let's have index table items dot add, and you'll notice it says this takes a key and a value. Let's have the key, which is T0 dot to string, and then it wants the value, and it's asking for a list of strings, and because this key doesn't exist yet, we have to create a new list of strings, and then we can pop in our current value T into that list. Close off our brackets and close off our line. Okay, so we have our dictionary set up once that runs. We need one further variable, and this is to hold our keys. So this is going to be a string called keys, or an array called keys. And let's set it down here underneath the for each loop. Keys is equal to index table items dot keys dot to array, and want to right click to array and include the system link. Okay, so now we have our keys, and we're going to see why we need those in a little while. At the moment we have a dictionary. So inside of our class we need a few further methods that allow us to divide this whole thing up into sections. The first is override number of sections, and then we want to return the keys dot length, and this is where this keys array is starting to come in handy for us. Okay, now we need to modify the rows in section, because we're no longer using our table items, we're actually using our dictionary. So we're going to return the indexed table items. We're going to grab, first of all, the section, so keys section, and then we're going to count the number of rows in that section inside of the dictionary. Okay, we need another method, and this is the section index titles, because at the moment our app doesn't know what to display down the right hand side for the shortcut icon things. And this again is an override section index titles, and then all we have to do is return that handy keys that we created earlier. Then of course we come down to our get cell, and we're no longer using these table items, so we can remove everything in here. Then let's pull our data out of our indexed table items, and first we need to get the keys. We need the index path dot section of our currently selected cell. Then we need to grab the index path dot row of the current section. So this is quite a nested little section here, but what it's doing is grabbing the section that belongs to the current key that we've selected. Then once it's got that section, it's looking for the row of that section we've selected. So that's how it navigates its way through this dictionary. Then of course this update cell requires 2 items. So what I'll do is I'll just put in a placeholder text, something like that. It's not important. Alright, save that. Let's run it inside of our app, and we should now have an index that shows us where we currently are inside of our scrolling list view. So there we have it on the right hand side, and we have our items. And if we click the items on the right hand side, or the index, it automatically scrolls to where we need to be. And that's why I made these cells really large, so we had somewhere to scroll to. Otherwise you wouldn't see anything when we clicked the index. Okay, that concludes how to make sections inside of iOS. I'll just go over what we did. We changed our list of table items. We then modified our table source to create an index dictionary inside of this for each loop. We made a set of keys that held all of those indexes from the dictionary. We checked the number of sections we required, the rows in each section. We got the index titles, and finally we changed the getCell method. At the moment we have a list of items inside of our app, and we have an index. What if we wanted to display a header that tells us what section we are currently in? Well, that's mighty simple to do. Inside of your UITableView source, let's have a public override, and we want the title for header. Then we can return our keys, and we can use the section that's passed in up here. We can also have a footer. So let's have override title for footer, and we can return section end. Now when we hit play, we should have a header and a footer for each section, which allows our user to quickly understand where they are in the list. So we have A, section end, B, and Z. So you'll notice these are sticky. If you look at the top, the A and B stick to the top. So iOS is very good at that, of letting you know exactly where you are in a scrolling list. Now this is a common one. How do you modify the header or the footer views? I'm going to show you. Let's have another overridden method. Override get view for header. Now this returns a UI view that your system can use for the header. So first of all, we have to create one. Var view equals a new UI view, and then we can initialize this with a frame. So let's have core graphics.cgrect, and we're going to have this starting at 0, 0, which is the top left corner. How wide do we want it? Let's have tableview.bounds.width, so it matches the width of the table view. And then we need a height. Let's set it to 44F. Close off our brackets. Now, just before we continue with this view, this height is important. iOS will ignore it for now. So we have to explicitly set it in another overridden method, which is getHeight for header. Then inside of there, we're going to return our 44F. So now it should all fit nicely. Our view needs something to display. Let's make a really simple label. Equal to new UI label. You should be used to this by now. And then let's give this a nice font. Equals to UI font.from name. Let's make this Helvetica and a size of 22F. Now this needs a frame. It needs to know where it is. And if I'm not mistaken, this frame that we're about to create is going to look at the view that it's available in and position itself relative to that view. I'm not quite sure about that, so don't quote me on it, but I believe that's the way it is. So we have our CG rect. We want to bring this in a bit from the left, so 10. Bring it in from the top, 5. How wide do we want it? Let's have it the full width of the table view. And how tall do we want it? Let's try 25. Then let's set a funky text color of plain old red. And finally, we need some text. And this text is simply going to be keys section. And close off our label. The label is created. Now we need to add that label to the view. So view.add. And pass it over our label. And finally, we're going to return this view. Now let's hit play. And hopefully we should have, we have a slight error. Expression, let's see what it says, denotes a type. That's because I haven't actually created a new Core Graphics CG Rect. And now when we hit play, we should be good to go. So with any luck, we're going to have some nice headers with a bit of red text that shows the index. And there we have A at the top, B and Z. It's as easy as ABC. Sorry, bad joke. Right. That concludes how to change the header view, the header title, and indeed how to put headers in. It's much the same story for your footers. So you can also get a view for footer method, and that's exactly the same as get view for header. Congratulations! You've completed this section on table views in Xamarin iOS. Don't be afraid to come back and redo these tutorials in case you don't make apps for a few months and you want to get re-familiar with table views. It's absolutely worth it to know what's going on because you're always going to use them. Right, in this section we've learnt what a table view is, we've learnt how the data source is used to orchestrate the cells and the bits of data. You created a basic table view with a standard basic cell. Then we looked at where it's at. You learnt how to create a custom cell, which meant you could have any kind of cell your heart desired. Finally, you created sections that allowed a user to see where they were in the list at any one time. They could also use shortcuts on the right-hand side, and when they touched them, it would take them to a certain part of the list. Finally, you learnt how to customize the views of the headers and footers.